Welcome back, everyone, to AI Paper Podcasts. Today we're diving into Apple's latest paper, Robust Autonomy Emerges from Self-Play. And it's a pretty wild one. They trained an AI to drive.
Entirely in simulation.
Yeah, you got it.
No human data.
And get this.
It works.
Not only does it work, it's actually beating AI drivers that were trained on real-world data sets.
Yeah, it's crazy, right? Like,
It's nuts.
state-of-the-art performance on these benchmarks like RLA Newplan and Waymo's Waymax.
It's like they dropped this AI into a brand new world and it just aced the driving test first try.
Like, it's just born to drive.
Yeah, seriously.
And a big part of this is their custom simulator that they built called Jugaflow.
Oh yeah, Gigaflow, that's the secret sauce, right?
Yeah, it's not your average driving sim. We're talking massive scale.
Yeah, like how massive are we talking?
42 years of driving experience simulated every hour on a single 8 GPU node.
That's insane.
It's a lot of driving, and the paper argues that this massive scale is what lets the AI develop like such robust and realistic driving skills.
Okay, so let's unpack this for a second. Because self-play, right? We usually think of that as something that works really well in competitive games.
Yeah, like Go or StarCraft or something.
Right, exactly. So how did they apply that to something like driving? Where, it's not about winning, it's about navigating this complex world safely.
Yeah, that's a good question. So basically, Gflow simulates this simplified world with roads and traffic lights and a whole bunch of these AI agents.
Right.
And all these agents learn to drive by just interacting with each other. But here's the twist.
Okay, I like twists.
The researchers actually randomized how much each agent cares about things like reaching goals, avoiding collisions, and following the rules of the road.
So you've got some AI drivers that are super cautious and some that are like total maniacs.
Yeah, basically. Yeah. Like, some are going to be weaving through traffic, cutting people off, running red lights.
It sounds like a recipe for disaster.
It kind of is, but that's actually the point.
Oh.
This chaotic mix of driving styles, it forces the main AI driver to become super adaptable.
Oh, so it can't rely on, other cars behaving predictably.
Exactly. It has to learn to handle all sorts of crazy situations.
It's like a driving school from hell.
Yeah.
But it produces this AI driver that can handle anything.
Right, and that's probably why it performs so well on those zero-shot benchmarks.
Right, the zero-shot benchmarks. Okay, so let's walk through those quickly. First up, we've got CarLA.
Yeah, CarLA.
And this benchmark is all about testing the AI on those really common accident-prone scenarios.
Exactly. Those like really tricky situations like pedestrians darting out into the road, sudden braking, crazy intersections.
Yeah, the kind of stuff that makes even an experienced human driver, kind of nervous.
Yeah, for sure. So did our self-play champ crack under pressure?
Nope, not at all. It sailed through those challenging situations.
Like it was nothing.
Like it was nothing. And it actually outperformed AI drivers that were specifically trained on CarLA's data set.
Which is pretty wild because it shows that those skills learned through self-play can actually transfer to completely different driving environments.
That's really impressive. Okay, so what about Newplan? That one's all about realism, right?
Yep, Newplan uses like real-world maps and driving data.
So it's less about those edge cases and more about, can the AI handle the kind of everyday complexities of driving?
Right, exactly. Like navigating through dense traffic, making lane changes smoothly, all that stuff.
So did our AI driver pass the realism test?
It aced it. It drove competently and once again outperformed other AI drivers that were trained specifically on the Newplan dataset.
So it's like it learned the unwritten rules of the road just by messing around with other AIs in Gflow.
It's crazy, right?
That's pretty wild. Okay, so 2 for 2. What about Waymax, the big one?
The big one, yeah, because this one's based on Waymo's massive real-world driving data set.
Right, we're talking mountains of data.
Mountains and mountains.
Of human driving experience.
Exactly. So it's like the ultimate test for our self-play AI.
Drumroll, please.
Did it disappoint?
Did not disappoint.
It held its own against and even surpassed some of the AI drivers that were trained on that massive Waymo data set.
So this self-play AI is not just competent. It's like top tier.
It's the real deal.
Yeah. Okay, so we've established that this AI can drive. But what I'm really curious about now is how does it actually think? Is it just a black box, or can we actually understand, its decision-making process?
That's a great question, and luckily the paper actually dives into that.
Oh, really? Okay, I'm all ears.
They go beyond just the benchmark scores, and they analyze how the AI makes decisions.
So like peering into its mind.
Exactly, trying to figure out what's going on in there.
I love it. Okay, so spill the details. What did they find?
So one of the things they did was they visualized the AI's value network and how it assesses risk.
Okay.
And it turns out it actually correctly identified dangerous areas, like taking corners too fast or being too close to other cars.
So it's not just reacting blindly, it's actually understanding the risks.
That's right. It's evaluating the situation just like a good human driver would.
That's fascinating. Okay, so what else did they uncover?
They also looked at the AI's attention, where it focuses its attention while it's driving.
Yeah.
And guess what? It focused on the most relevant cars around it, just like a human driver would. You know, ignoring irrelevant ones off in the distance.
So it's not just processing everything in its field of view, it's actually prioritizing.
Yeah, exactly.
Okay, that's really cool.
It suggests that it's developed this sense of situational awareness, which is pretty incredible. And then maybe the most impressive part is that the AI actually showed signs of long-term planning.
Okay, hold on. Long-term planning, like how long-term are we talking here?
Well, it was able to reroute itself around obstacles that were pretty far down the road.
Wow.
So it's not just reacting to the immediate situation, it's actually thinking ahead.
That's some next-level driving awareness.
Right.
Okay, so it sounds like this research is really pushing the boundaries of what we thought was possible with self-play and AI. But this is just the beginning of our exploration. We've got a lot more ground to cover, so make sure you stay tuned for part 2, where we'll dive deeper into the technical details of GigaFlow and the AI's training process. Don't miss it.
Welcome back to AI Paper Podcasts. We left off last time kind of marveling at this AI driver that was trained entirely through self-play.
Yeah, somehow it managed to beat AI that was trained on actual human data. It's wild.
I know, right? And it's all happening inside this custom simulator they built called GigaFlow.
Yeah, GigaFlow, with AI was racking up virtual miles like crazy.
42 years of driving experience simulated every hour on just one 8 GPU node. It's insane, the scale of this thing. But I'm curious, what's under the hood of GigaFlow? What makes it so special?
Yeah, I want to get into the technical nitty-gritty here. How do they build a simulator that can handle this massive self-play training?
So one of the key things is that GigaFlow is designed for parallel processing. It can run thousands of these simulated environments at the same time on a single machine.
So it's like a gigantic virtual city with thousands of these AI drivers all learning at once.
Exactly. And because it's built with GPUs in mind, they can just crank through these simulations at an incredible speed. That's how they hit that 42 years per hour number.
Okay, speed is one thing. But what about the environments themselves? Are we talking super realistic graphics like detailed cityscapes? Because I know that realism in simulation can be really computationally expensive.
Yeah, actually they went for a more minimalist approach. The environments are actually simplified. They focused on the core elements of driving, so roads, traffic lights, and other cars.
So it's less about the visual fidelity and more about capturing the essential dynamics of driving.
Exactly. They traded graphical realism for sheer scale and speed. And remember, the real secret sauce here is the diversity of those other AI agents.
Oh, right. The AI agents with their randomized reward preferences.
Exactly. You've got some that are cautious, some that are aggressive, some that probably drive like your grandma.
It's a wild mix.
It is, and that's where the real learning happens.
Yeah.
The main AI driver has to figure out how to navigate this world full of unpredictable drivers, which makes it, incredibly robust and adaptable.
It's like a crash course in defensive driving, but on this massive simulated scale.
That's a great way to put it. Now let's talk about how the main AI actually learns in this crazy simulator. It all boils down to reinforcement learning.
Oh yeah, reinforcement learning.
Yeah.
That's where the AI learns through trial and error.
Exactly. It tries different actions and it gets feedback based on, whether those actions lead to good or bad outcomes.
So if the AI does something good, like safely navigating a busy intersection, it gets rewarded.
Exactly. And if it makes a bad decision, like cutting someone off or running a red light, it gets penalized.
And over time, it starts to figure out which actions are more likely to lead to those rewards.
Right. And it adjusts its behavior accordingly. But here's where things get really interesting. The reward system itself is actually pretty complex.
Oh, I'm intrigued. Tell me more.
It's not just about reaching the destination. They designed the reward system to actually encourage good driving habits, like staying in lanes, maintaining a safe following distance, and obeying traffic laws.
So they're not just training an AI that can drive, they're training one that's a good driver.
Exactly.
Yeah.
They want an AI driver that wouldn't make other drivers, want to pull their hair out.
Makes sense. Nobody wants an AI driver that's weaving through traffic and cutting people off.
Yeah.
But wouldn't this make the AI too cautious? Like sometimes you need to be a little assertive. Like when you're merging onto a busy highway.
Yeah, that's a valid point. And it's something the researchers addressed through that randomization we talked about with the other AI agents.
Right. So even though the main AI is being trained to be a good driver, it still has to deal with other AI drivers that might be aggressive or unpredictable.
Exactly. That's crucial. It forces the main AI to develop this broader range of driving strategies and adapt to unexpected situations.
Okay, so we've got this massive simulator, a sophisticated reward system, and a diverse cast of AI drivers. But simulating billions of kilometers of driving seems like it would take forever. How did they make the training process efficient?
Yeah, good question. They used a few clever tricks. One of them is called advantage filtering. It's a way of focusing on the most informative data during training.
So instead of processing every single second of the AI's driving experience, they identify those moments that are most crucial for learning.
Exactly.
Yeah.
They filter out those mundane parts and prioritize the moments where the AI faces difficult choices, where its decisions really matter.
So they're like fast-forwarding through the boring parts and focusing on the action-packed moments.
Exactly. And by doing this, they can really speed up the learning process.
Makes sense. It's like giving the AI a highlight reel of all the most important driving experiences.
Exactly. Now, another important optimization is they use this compact and efficient neural network architecture. This is the brain of the AI, the part that processes all the information and makes the decisions.
Okay, so they designed the AI's brain to be as streamlined and powerful as possible.
You got it. They optimize the architecture to have fewer parameters, which makes the learning process much faster.
So they're squeezing every ounce of performance out of their system.
They are, and it really shows in the results. They managed to train an AI driver that performs incredibly well without any human data, and they did it with a relatively small network.
That's impressive. It means this kind of technology could be more accessible and scalable in the future. But before we move on, they mentioned something about reconstructing observations during training. What was that all about?
That's another clever trick to save memory and make training faster. They're simulating thousands of these environments at the same time, right? And each environment contains a ton of information.
Right, things like the position of the car, the traffic lights, the other cars.
Yeah.
It all adds up.
Exactly. So instead of storing all that info for every single step, they only store the essential data. Then when they need it, they just reconstruct the other information on the fly.
It's like compressing a file to save space and then decompressing it when you need it.
Perfect analogy. This lets them reduce the memory footprint of their simulations without sacrificing the quality of the training data.
That's brilliant. They've optimized everything from the simulator to the training process to the neural network.
They really have. And the result is this remarkable system that can train an AI driver in simulation without any human data. But the question is, how does this self-trained AI perform when you put it up against those real-world driving benchmarks? That's what we'll be diving into in part 3, so stay tuned.
Welcome back to AI Paper Podcasts. We've spent the last 2 episodes really digging into this Apple paper, where they trained an AI to drive entirely using self-play in their crazy simulator GigaFlow.
And we saw how incredibly efficient and powerful GigaFlow is, capable of simulating a ridiculous amount of driving data.
42 years of driving experience per hour on a single 8 GPU node. Still blows my mind.
It's pretty wild. But of course, the real test is how this AI driver performs when you put it up against, real-world driving benchmarks.
Right, because simulation is one thing, but the real world is a whole other ballgame. Yeah. So how did their AI do?
Well, they tested it on 3 different benchmarks, Carle, Nuplan, and Waymax. Each of these benchmarks kind of tests different aspects of driving performance.
So let's start with Carle. This one is known for being pretty tough. It throws all sorts of challenging, accident-prone scenarios at the AI driver.
Right. Things like pedestrians suddenly darting into the road cars, cutting you off unexpected obstacles. Stuff that would even make a human driver, pretty nervous.
So how did our self-play AI handle the pressure?
It passed with flying colors. Not only did it navigate all these situations safely, but it actually outperformed AI drivers that were specifically trained on the SAR-RLA dataset.
Wow, so it's not just surviving, it's thriving in these tough conditions.
Exactly. It really shows that the skills learned through self-play in GigaFlow can generalize to a totally different environment.
That's super impressive. Okay, so Carle tested its ability to handle those really difficult edge cases. What about Nuplan? How did it do there?
Nuplan is all about realism. It uses real-world maps and driving data to try to create this really accurate representation of, everyday driving.
So less about crazy situations and more about can it handle the normal complexities of driving on real roads?
Exactly. Things like navigating dense traffic, making lane changes smoothly, anticipating the behavior of other drivers, basically driving like a normal, competent human.
Okay, so did our self-play AI fit in with the rest of the simulated traffic?
It did more than fit in. It actually outperformed AI drivers that were specifically trained on the new plan dataset.
Wow, so again, it's not just keeping up, it's exceeding expectations.
It really highlights how powerful self-play can be, even in a simplified simulated world.
Yeah.
It can still learn these really nuanced behaviors that are necessary for real-world driving.
Okay, 2 down, 1 to go. And this last one is the big leagues, Waymax. This is the benchmark that's based on Waymo's massive real-world driving dataset.
Yeah, which means that our self-play AI is going up against AI drivers that have learned from a ton of human driving data.
This is the ultimate test.
Yeah.
So how did it do?
It actually performed amazingly well. It surpassed the performance of some of the AI drivers that were trained on the Waymo dataset.
Wow, are you serious? That's incredible. It's like someone who taught themselves to play an instrument and then went head-to-head with graduates from a top music school and won.
It's a really powerful demonstration of the potential of self-play. It shows that, maybe learning from simulated experience can be just as good as or even better than learning from human-generated data.
That's a pretty bold statement. But it's exciting to think about the possibilities.
Yeah.
This research has really opened my eyes to what self-play can achieve. But I also want to be realistic here. What are some of the challenges and limitations of this approach?
That's a good point. One of the biggest challenges is bridging the gap between simulation and reality. Simulators are incredibly valuable tools, but they can't perfectly replicate the real world.
Right, there's always going to be something unexpected that happens on the road that you just can't program into a simulator.
Exactly.
Yeah.
Simulations are great for training and testing these fundamental driving skills, but there are still a lot of real-world factors that the AI will need to learn to handle.
Things like unexpected weather conditions, road construction, crazy drivers, stuff like that.
Right, and that's where things get tricky, because you can't really simulate every single possibility.
Yeah.
So while this research is incredibly promising, it's important to remember that it's still early days.
So the next step is to take these self-learned skills and see how they transfer to an actual car driving in the real world.
Exactly, and that's a whole other challenge. It involves integrating this AI with all the sensors, actuators, and safety systems of a real car, and then ensuring that it can handle all those unpredictable real-world situations.
It's definitely a big leap from simulation to reality. But if they can make it work, the potential benefits are huge. Imagine self-driving cars that are trained entirely in simulation without needing any data from human drivers.
That would be a game changer. And it's not just limited to driving. This kind of self-play approach could be applied to all sorts of fields, from robotics and manufacturing to healthcare and finance.
It could really revolutionize how we develop intelligent systems.
Absolutely. This paper really is just a glimpse into what might be possible with self-play. It's exciting and a little bit scary at the same time.
Definitely. But one thing's for sure, the world of AI is moving fast. And research like this is pushing the boundaries of what we thought was possible.
Absolutely. So I think that wraps up our deep dive into this paper about self-play for autonomous driving. We covered a lot of ground.
We talked about the incredible simulator they built, the AI's impressive performance on real-world benchmarks, and the potential of this approach to really change the future of AI.
And who knows what amazing breakthroughs are just around the corner.
That's right. So until next time, keep exploring the world of AI and all the exciting advancements that are happening every day. Thanks for joining us.
Thanks for listening.